So in today's class we are going to discuss an important problem in Maxima and Minima. So here we'll discuss the problem, prove that the function f of x is equal to log x divided by x has a maximum value at x equal to e. So here we have to find the maximum value of this function which occurs at x equal to e, where e is the exponential number. So let us solve this problem. So here we'll make use of the second derivative test. So let us first differentiate the function f of x. Now the derivative of the function f, that is f prime of x, is d by dx of log x divided by x. So here we have the quotient of two functions, so we'll make use of the quotient rule for differentiation, that is d by dx of f over g. If we have two functions f and g of x, then we have g times derivative of f, and then we have f derivative of g divided by the square of the function g. So let us apply this rule to differentiate this function. So we have f prime of x is equal to x derivative of log x, then we have log x and derivative of x, right, and divided by x square. So simplifying the numerator, we have f prime of x is equal to x times the derivative of log x is 1 over x minus log x, and derivative of x is 1. So we have in the denominator x square. So here x and x get cancelled, so we have 1 minus log x divided by x square. So here the derivative of this function is 1 minus log x over x square. Now in order to find out the stationary points or the turning points, we should equate the first derivative equal to 0, right? So now f prime of x is equal to 0. It means 1 minus log x divided by x square is equal to 0. And if we solve this equation for x, we have 1 minus log x is equal to 0 and log x is equal to 1, and log x is equal to 1 for x is equal to e, right? Because log of e to the base e is 1, right? So this is equal to log of e, so x is equal to e. So here the turning point is x equal to e. Now let us find the second derivative of the function f. So let us differentiate it, and we have f double prime of x is d by dx of 1 minus log x divided by x square. Now here again we'll apply this rule. So the second derivative becomes x square times the derivative of 1 minus log x and minus 1 minus log x times derivative of x square, right, and divided by x square raised to square. So now if we simplify it, then we get x square times the derivative of 1 is 0, the derivative of log x is 1 over x, minus 1 minus log x, and derivative of x square is 2x, right, and divided by x raised to 4. Now if we simplify the numerator, then we get f double prime of x is equal to, here x and 1x get cancelled, so we have minus x, and here we have minus 2x multiplying this term by 2x, so we have minus 2x plus 2x log x, right, 2x log x, and divided by x raised to 4. So now we have f double prime of x is equal to, here minus x and minus 2x is minus 3x and plus 2x multiplied by log x divided by x raised to 4. Now cancelling 1x from this denominator, so we have f double prime of x is equal to minus 3 plus 2 log x, right, divided by x cube. So the second derivative of this function f is given by minus 3 plus 2 log x divided by x cube. Now here we will apply the second derivative test. So we'll substitute the value of this x is equal to e in this expression, and let us see what we get. So for x equal to e, the value of the second derivative is equal to minus 3 plus 2 log e divided by e cube, right? So this is minus 3 plus 2, because log e is 1, so we have my plus 2 times 1 is 2 divided by e cube, and this is minus 3 plus 2, that is minus 1 divided by e cube. So now we conclude that the value of the second derivative at x is equal to e is negative, and that is less than 0, because e is exponential number and e is always greater than 0. So this term, that is minus 1 divided by e cube, is always less than 0. So the second derivative is less than 0 at x is equal to e. So by second derivative test, we conclude that this function f has a maximum value at x is equal to e, and the maximum value is given by f of e, that is log e divided by e, and log e is equal to 1, so we have here 1 divided by e. So the maximum value of this function occurs at x equal to e, and the maximum value of the function is f of e, that is equal to 1 over